Welcome back to the deep dive.
Yeah.
Now, if you've ever walked into, say, a massive university lecture hall, or maybe a really modern corporate meeting center.
Or even the control room at a stadium, yeah.
Exactly. You're looking at this incredibly complex information traffic jam, really. You've got potentially hundreds of sources.
Laptops, cameras, media players.
Right. And they all need to reliably get to dozens of screens, often spread out over huge distances.
And if that system hiccups, I mean, everything just grinds to a halt. It's high stakes.
Definitely. So today we're diving into the hardware that often acts as the central nervous system for those big environments.
We are. We're looking at the Atlona AT-HDR-MX1616 Matrix Switcher. This thing is really designed as the powerhouse for high-density routing.
High dynamic range, too, right, HDR.
Absolutely. High dynamic range. It handles 16 inputs going to 16 separate outputs, all at the same time.
Okay, so our mission today isn't just, reading off a spec sheet.
No.
We want to understand why a device like this specific one is, well, the trusted workhorse in the AV world. What does it actually do technically?
Yeah, what problems does it solve for the people installing and running these massive systems? Things like video quality, distance, control complexity.
Managing all that at once.
Yeah.
That's the challenge. Okay, so let's unpack that. Starting with the scale. You said 16 by 16 switcher.
Yep.
So 16 HDMI inputs. That covers, I guess, 16 different laptops, media servers, whatever you throw at it.
Pretty much any source you'd find in those environments.
But the output side,
Yeah.
that seems interesting right away. It's not just 16 outputs.
Well, it is, but how they're structured shows it's built for complex installs. You've got 16 HDBaseT outputs.
Okay, that's for the long distance runs. We'll get into that.
Right. But here's the key detail, something easily missed. Each one of those HDBaseT ports has a mirrored HDMI output right there on the back of the unit.
Mirrored. So an identical signal.
Identical signals simultaneously.
I could see that being useful. So if you're sending the signal, like 300 feet away over HDBaseT to a big projector.
You can also plug a small monitor directly into the HDMI port right there in the equipment rack.
Why would you need that? Just to check it's working?
Yeah, exactly. It's perfect for confidence monitoring or troubleshooting. Or maybe you need to feed a local recording device or split the audio off right there.
Okay, got it. So you always have that local tap point.
For every single one of the 16 outputs, it gives you incredible flexibility right at the rack.
That makes sense. Now, quality. Switching 16 signals is one thing, but keeping them looking perfect is another challenge entirely.
It really is.
The specs mention 4K UHD resolution at 60 Hz. Okay, that's standard high-end now. But also 4.4.4 chroma sampling. Let's translate that. What does 4.4.4 actually mean for someone watching?
Right, so it's all about color detail. A lot of video, especially compressed stuff online or even broadcast, uses something like 4.2.0 chroma sampling, which basically throws away some color information to save bandwidth. Fine for movies, maybe.
But not for detail.
Exactly. If you're looking at sharp text, like on a spreadsheet or detailed computer graphics or medical images, 4.2.0 can make the edges look a bit fuzzy or colors can bleed slightly. 4.4.4 means every single pixel gets its full unique color information. No compromises. It keeps fine lines and text absolutely crisp.
So crucial for presentations, control rooms, that sort of thing.
Absolutely mission critical there. And handling that quality means you're pushing a lot of data up to 18 gigabits per second.
Wow.
Which also means it has to be fully HDCP 2.2 compliant.
That's the copy protection handshake, right?
Yep. The digital content police, without HDCP 2.2 support, you couldn't reliably pass through protected 4K content from sources like Blu-ray players or streaming boxes.
Got it. So the big takeaway here is this isn't just for today's 4K. It's really built for the best possible quality, including those HDR formats.
Exactly. HDR10, HLG, Dolby Vision.
Yeah.
It's designed to handle the highest quality signals sources can currently output. Future-proof, really.
Okay, speaking of throwing signals, let's talk distance. That's the other huge hurdle in big venues. Standard HDMI cables, they kind of give up after, 50 feet? Maybe less for reliable 4K?
Yeah, you're pushing it much beyond that. They become unreliable, expensive, or just don't work.
So how do you get that pristine 4K HDR signal across a whole university campus or a stadium without degradation? Or spending a fortune on fiber.
That is exactly where HDBaseT comes in. It's the industry standard technology specifically designed for this.
Okay.
It takes those really high bandwidth HDMI signals and cleverly bundles them so they can travel reliably over standard, inexpensive network cable, like Cat6a.
Just regular network cable, the same stuff used for computers.
Pretty much, yeah. Category 6A is recommended for the full distance and performance, but it's readily available and much easier to install than specialized video cables.
So if I'm the installer running maybe 16 of these Cat6a cables, potentially 300 feet or more,
Yeah.
what's the biggest risk? Signal loss, interference.
Signal integrity over distance is always a concern, yes. And also, think about powering all those displays at the far end. That's 16 power outlets you need potentially hundreds of feet away.
Ugh, nightmare.
Right. So this Atlona box uses HDBaseT to tackle both. It extends the signals up to 330 feet, that's 100 meters, over that Cat6a cable.
330 feet. That covers most large rooms, even complex buildings.
It does. And the real magic, as you hinted earlier, is what HDBaseT squeezes down that single cable. It's not just video.
Right, you said 5 signals.
5 signals simultaneously. You get your 4K HDR video, obviously. You get multi-channel audio. You get Ethernet for network connectivity to the display if it needs it.
Okay.
You get control signals, bidirectional RS-232 and IR, plus CEC commands for basic stuff like power on-off.
So you can control the display from the rack room.
Exactly. And the fifth one is huge. Power. It sends power over HDBaseT, or POH.
Meaning, no power adapter needed at the display end.
Correct. The switcher itself powers the compatible HDBaseT receiver at the display end right over the Cat6a cable.
Wow, that simplifies installation massively. No need for electricians to run power to every single display location.
It's a huge cost and time saver on big projects, a massive advantage.
Definitely professional grade. Now, I saw a mention of maintaining that 4K 60, 4.4.4 quality over that long distance.
Yeah.
Something about visually lossless compression with no latency.
Yes. Good point.
Let's pause on that. Visually lossless. Does that mean it is compressed? Just. You can't tell.
Essentially, yes. To fit that massive 18 Gbps signal down a Cat6a cable reliably, some very clever, very light compression is used.
But it's so good you can't perceive it.
Exactly. The algorithms are designed so that, to the human eye, the image at the far end is indistinguishable from the original source. No artifacts, no banding, nothing.
And the no latency part, that's critical too.
Absolutely critical, especially in live environments or control rooms. Latency is delay. If you push a button to switch cameras and the image takes even half a second to change.
That could cause major problems in a live broadcast or a security setting.
Totally. So this compression happens practically instantaneously. Zero discernible delay. You maintain perfect image integrity and real-time responsiveness.
Good to know. And it looks like they have options for receivers depending on distance.
Yeah, the main one is the AT-HDR-MX1616 for that full 330 feet. But if you have shorter runs, say up to 130 feet or 40 meters, there's a slightly simpler, less expensive receiver, the AT-HDR-EX70CRX. Gives you options.
Okay, so we've tackled distance and video quality.
Yeah.
But, in these big systems, sometimes audio feels like an afterthought, even though it's just as important.
It often gets complicated, yeah. Especially getting audio to separate sound systems.
Right, so how does this Atlona Matrix handle sound? Does it just pass through the HDMI audio?
It does much more than that, which is another reason it's a pro-level device. It has a completely independent built-in audio matrix.
An audio matrix, separate from the video switching.
Yes. What it does is it takes the audio from the incoming HDMI signal specifically. It can grab up to 16 two-channel PCM audio streams.
Okay, standard stereo audio.
Right. And the key step is it de-embeds that audio. It pulls it right out of the HDMI stream before the video even gets routed.
Why separate them? Why de-embed?
Because often your video screen and your speakers aren't in the same place or aren't part of the same system. Think about a lecture hall.
Okay.
The video goes to the projector via HDBaseT, but the audio might need to go to the room's main amplifier and speaker system, or maybe to an assistive listening system, or even a recording feed.
So you need to send the audio somewhere totally different from the video.
Precisely. By de-embedding it, you break that link and gain total flexibility.
Makes sense. So where does that separated audio go? How does it get out of the box?
It gets routed to 16 dedicated analog audio outputs on the back, unbalanced stereo on standard terminal block connectors.
So easy connection to pretty much any professional audio amplifier or mixer?
Exactly. It makes integrating with those dedicated multi-zone audio distribution systems much, much simpler.
And you have control over that audio.
You do. Each of those 16 analog audio outputs has its own independent volume and mute control accessible through the control system.
So you can adjust levels for different zones right from the matrix. That's pretty neat.
It really streamlines things. You don't need as much external audio processing, potentially.
Speaking of control, let's look at managing the whole switcher. For something running potentially 204/7, reliability and ease of control are paramount.
Absolutely. You need multiple ways to talk to it, depending on the setup.
What are the options here?
Well, you've got the front panel buttons for direct access, of course,
Mhm.
but realistically, in these big systems, it's going to be controlled remotely.
Right.
So it has a built-in web server, which gives you a really intuitive graphical user interface, a GUI just through a web browser.
So the IT folks or AV techs can just log in over the network.
Yep. And for integration with dedicated control systems like Crestron, AMX, platforms like that.
The standard professional systems.
Right. It supports control via TCP/IP over the network, or traditional RS-232 serial commands, and even basic IR remote control. It covers all the bases.
That flexibility is key for installers. Makes programming easier.
Definitely. And there's one more control feature worth mentioning, CEC.
Consumer electronics control. That's the thing where your Blu-ray player can turn on your TV.
Sort of, yeah. This switcher can use CEC commands triggered automatically or via TCP/IP or RS-232 to control display power turning screens on and off at the far end over both the HDBaseT connection and those mirrored HDMI outputs.
Oh, that's handy. So the system can automatically power everything down at night or power up specific rooms on schedule.
Exactly. It simplifies daily operation and ensures things aren't left running unnecessarily. It really adds to that reliable, integrated feel. So if you tie all these pieces together, the high density 16 by 16, the mirrored outputs, the HDBaseT extension with POH, the audio de-embedding, the robust control.
It paints a picture of a very specific type of device for a very specific need.
It really does. This is a serious piece of infrastructure.
Mhm.
It's a 4U rack-mountable unit, actively cooled with fans. It's built for heavy lifting in demanding places.
So where do you actually find one of these things humming away in a rack? It's not for your living room home theater.
Definitely not. The primary applications are exactly those complex environments we talked about at the start.
Like universities.
Absolutely. Large university AV systems, distributing lectures or digital signage across campus buildings.
Mhm.
Corporate environments are big too, training facilities, large boardrooms, command centers.
Okay.
Hospitality comes up, big conference centers, hotels with lots of meeting spaces, sports venues for feeding all those screens around the stadium, and dedicated control rooms like for security or traffic management.
Anywhere you have lots of sources that need to get reliably to lots of screens, often far away.
That's the core value proposition. Centralized inputs, dependable routing to multiple displays across a large footprint without needing, 16 separate little extender boxes for every single connection.
It consolidates everything.
Right. And that reliability factor is underlined by things like its compliance with NDAA 8999.
Which is important for government or federal projects.